Module 5, Lesson 3 deals with subtracting linear equations. If you could do the adding linear equations we did in Lesson 2, well, you should then be able to subtract linear equations as well. Our content objective is students will subtract linear equations and express their difference in simplest form, and it suggests that we're going to knock this puppy out in a single day, so let's see if we can do it in a single video. In a recent FIFA Women's World Cup, I have no idea what that is. I guess it's soccer based off the image. The United States outscored Japan by a score of 5-2 in the final match to win the World Cup. In soccer, a shot on a goal is an attempt to score the goal that either results in a goal or results in a save by the defending team. Over the course of the entire tournament, the United States had 8x plus 1 shots on the goal, and Japan had 7x plus 7 shots on the goal, where x represented the number of shots on the goal the United States had in their first game. Because, I mean, doesn't every sports enthusiast write their shot records in the terms of algebraic expressions? Yeah, sure they do. How can you determine the total number of shots on the goal one country had? Let's read this again. How can you determine how many more shots on the goal one country had than the other if the United States scored 2 goals in the first game? These are the things we're going to learn about in this lesson. When two expressions have a sum of 0, the expressions are additive inverses. We've already discussed this before and defined that term. To find the additive inverse of an expression, use a distributive property to multiply the expression by -1. So we want to find out what the additive inverse of 4x plus 2 is, and to do that we're going to multiply 4x by 2 times -1, and that will tell us what the opposite value of 4x plus 2 is. So in doing that, you use a distributive property. They took and said -1 times 4x right here and -1 times 2 right there. Simplify that down. -1 times 4x is -4x. -1 times 2 is -2. Last step, make your ugly problem pretty by multiplying your signs, and you get -4x minus 2. It really just doesn't get any easier than that. You can check this to see if 4x plus 2 and -4x minus 2 are additive inverses by adding them together to see if their sum is 0, and you can see when they did in fact get a zero-sum game there, where neither side actually won anything. Now it's going to be your turn. Find the additive inverse of 5x minus 7 and check your answer. Or maybe not, because this is not your problem. This is still an example problem. So we're going to start off by putting the -1 through the grouping symbol. Oh, no, wait a minute. This isn't a minus problem, so we have to make the pretty problem ugly, stretching it out there. Now we're going to multiply the -1 through the grouping symbols, which means you have -1 times 5x plus a -1 times the -7. From there, we're going to get, well, -1 times 5x is -5, and there's an x right there. And then -1 times 7 is going to become a positive 7, so we're going to check it. So we could say that the additive inverse of 5x minus 7 is going to be -5x plus 7. Pretty simple stuff. And now it's going to be your turn. You find the additive inverse of -8x plus 5. Go ahead. Is it my turn already? Alright, let's take a look at what I'm going to do. I'm going to take -1 times the original expression 8x plus 5. From here, I'm going to distribute my -1 through the grouping symbol. Because it's a positive number, I don't have to make the pretty problem ugly. So -1 times a -8x plus a -1 times a positive 5. From there, -1 times -8, that's going to become a positive 8x plus -1 times -5. That's going to become a -5. Last thing we have to do, make our ugly problem pretty. 8x minus 5. Circle your answer. Now we're going to come back over here and we're going to check our answer. 8x minus 5 and check. And we get the happy sound. When subtracting integers, you add the opposite, or the additive inverse. The same process is used when subtracting linear expressions, and we're going to watch this animation and let it show us how to do that.
To subtract linear expressions, start by arranging the like terms in columns. Next, use the additive inverse to rewrite the subtraction as addition. The additive inverse of 3y is negative 3y. And the additive inverse of 4 is negative 4. Next, add the like terms in each column. Add the like terms with variables, then add the constant terms. You have now found the difference of the original expressions.
Alright, that was pretty quick and simple. Basically what they did, they brought the first term down, and then they brought the second term down. They multiplied everything in the second term by -1. They didn't really show the work that they were doing here, but that's what they were doing. Getting a negative 3y minus 4, and from there it was just like the last lesson we did. And that takes us to example 2, which says find 6x plus 5 minus the difference of 3x and 2. So what are we going to do? Well, we're going to do exactly what they said to do. We're going to start off by, oh, well, maybe we're not. They want us to use algebra tiles first, so that's going to be a pretty cool thing to do. Use algebra tiles to model 6x plus 5, and then add the additive inverse of 3x minus 2, remove any zero pairs. Well, first off, we're going to take and deal with the 6x plus 5. So we're going to put our 1, let's make this smaller so I have some room to work with here. 2, 3, 4, 5, 6, and then 1, 2, 3, 4, and 5. So there's our 6x plus 5. And now we get to add the additive inverse of 3x minus 2, this value right here, and the opposite of 3x minus 2, well, that's going to be negative 3x plus 2. So I'm going to put 1, 2, 3, and then minus 2 became plus 2, 1, 2. So what's our final answer going to be? Well, we got to get rid of some zeroed pairs here, so let's work on that. I'm going to get rid of this pair of numbers. I'm going to get rid of this pair, actually variables, not numbers, and this pair of variables, and get up there. And what do we have left? We have 3x plus 7, so 3x plus 7 would end up being our final answer. Scroll down to the bottom, that would be answer C, hit check, and our answer checks. Now that we worked the problem using algebra tiles, it's going to be time to work it using columns instead. So let's take and go through the problem the way they'd want us to do it. We're going to take and start off by changing the problem here to be an addition problem where they're adding the additive inverse. They're showing it a little bit different this time, but it's the same thing they did before. So where they had minus 3x plus 2, they made this plus a negative 3x plus 2. I'm sorry, I think I said plus. That should be minus 2 right there. So they basically distributed that negative sign through the grouping symbols, making it plus negative 3x plus 2 here. And from there, it's just a matter of coming up with your columns. And from there, it's a matter of simplifying. 6x minus 3x, that's 3x. 5 plus 2, that's 7. Final answer is going to be 3x plus 7, which you could type in there if you want to, but I'm not going to do that right now. Alright, now it's your turn. Pause the video. Solve this problem. Check your answer. Well, how'd you do? Let me show you what I'm going to do. Follow the same format that they worked in their last problem, where I'm going to change the subtraction problem into an addition problem. So I have negative 4x minus 7. That gets left alone. And then we're going to do plus the negative. So we're going to do plus, and then that negative sign is going to get distributed through here. Negative times the negative, that's going to become a positive 5x, which we can write as just 5x. And then a negative times the negative again, that's going to become plus 2. From here, we're going to line our like terms. So I'm going to have negative 4x minus 7 plus 5x plus 2. Negative 4x plus 5x, signs are different. find the difference with a sign in front of the larger number going in front of your answer. That means you can have a positive 1x or just x. Negative 7 plus 2, signs are different. Find the difference with the sign in front of your larger number going in front of your answer. Final answer is going to be x minus 5, and check. And we did well on that one. But what if we had problems involving fractions? We'd work it the same exact way. So we're going to take in the problem that they gave us right here. Next step is going to be to rewrite it using the additive inverse. So we're going to click on that next button, and you can see where they had minus everything that was in here. They did plus and used the additive inverse. Positive 1/6x became negative 1/6x. Negative 3/8 became a positive 3/8. From there, it's going to be just a matter of aligning the columns that you see going on right here. So now we're going to have negative 2/3 x minus 1/6x plus 1/2 plus 2 3/8. Problem is denominators. We have uncommon denominators. That means we need to shoot off to the right there with a common denominator. The common denominator for the 3 and the 6 became 6. So now you have 4/6 minus 1/6. The common denominator for the 2 and the 8 became 8. So that became 4/8 plus 3/8. Now we're going to simplify. 4/6 minus 1/6, that's going to be 3/6x. And then 4/8 plus 3/8, that's going to become 7/8. But we're not done. 3/6 is not in simplest terms. We can simplify 3/6 down to be 1/2 x plus 7/8. And this number right here is what you need to put in your answer box. Alright students, now it's your turn. Pause the video, work the problem, make sure you're finding your common denominators, and check your answer. How'd it go for you? Well, let's see what I'm going to do. I'm going to start off by writing the first binomial, which is going to be 3/5 x minus 1/8. The first one never changes. The minus signs can become a plus sign, and then I'm going to distribute that minus through my grouping symbols. A negative times a positive, that's going to give me a negative 1/3 x. A negative times a negative, that's going to give me a positive 3/4. From there, we're going to align the like terms. So we're going to have 3/5 x minus 1/8 plus a negative 1/3 x plus a 3/4. Now we have to take and find the least common denominator. The least common denominator for 5 and 3 is going to be 15. So when I set up my problem, it's going to be a negative something over 15 on the bottom, a positive something over 15 on the top. 5 goes into 15 3 times. 3 times 3, well, that's 9. 3 goes into 15 5 times. 5 times 1, that's going to become 5. And then we're going to have a minus here. And what's our denominator going to be for 8 and 4? It's going to be 8. Something over 8 and something over 8. Of course, 1/8 stays the same. 4 goes into 8 2 times. 2 times 3 is going to be 6. And now we're actually ready. Oops, that one should be a plus sign there. Now we're actually ready to solve the rest of this problem. So now I've got signs are different. Find the difference. The difference between 9 and 5 is going to be 4, with a sign in front of the larger number going in front of the answer. So that's going to be 4/15 x. And here, signs are different again. Find the difference, which is going to be the difference between 6 and 1 is going to be 5/8, with a sign in front of your larger number going in front of your answer again. Everything's in simplest terms, so let's go back over here, and we're going to take and type in a fraction, 4/15x plus and 5/8. So hit another fraction, 5/8, accept, and check. And check, and our answer checks. Everybody's happy. Everybody gets a car. Yay! Alright, we have blown through this lesson pretty quick, so let's knock out the apply problem and be done with it. Bonnie owns a t-shirt shop where she sells plain t-shirts and printed t-shirts. The table shows the cost per shirt and the number of each type of shirt shown. After W weeks, over the course of W weeks. And it says after 25 weeks, how much more did she earn for printed t-shirts in sales than she did for plain t-shirts? Well, we need to find out the difference between the printed and the plain first. So the printed is going to become our first number. The plain is going to become what's subtracted from it. And with that, let's get a screenshot and get started on solving this problem. So, since we're going to be subtracting the printed from the plain, because it does tell us that the printed t-shirts are more. How much more did she earn on the printed t-shirts? That means the printed t-shirts are going to go first. That's the greater amount, 8W plus 3. And that's going to be subtracting from it your 5W minus 4. From there, we're going to take and say, well, make the minus problem into a plus problem. So I'm going to have 8W plus 3 gets left alone. Change the subtraction to minus and then distribute this negative sign through the grouping symbol. So negative times a positive became a negative 5W. A negative times a negative became a positive, positive 4 right here. Now we can align them. That's going to give us 8W plus 3 and a negative 5W plus 4. Put your plus sign there. 8 minus 5 leaves us with 3W plus 3 plus 4. That is going to be 7. And that is going to be the difference in the t-shirts sold. So they sold 3W plus 7 more printed t-shirts than they did plain t-shirts. But actually, that's just how many more they sold in 1 week. If you go back to your problem, you're going to see they had 25 weeks. So now we're going to take that 3W and we're going to make that into 3 times 25 plus 7, where 3 times 25 is going to be 75 plus 7, and that means that we're looking at a total of 82 more t-shirts sold that were printed instead of the plain ones. But we're not done. Now we have to take that 82 and multiply it times the $15. And doing that, 5 times 2 is going to be 10, 5 times 8 is going to be 40, plus 1 is 41, 1 times 2 is 2, 1 times 8 is 8, add those up, 0, 3, and 12, so you get $1,230 more that was made in the printed t-shirts than in the plain ones. Jump back over here to our problem and scroll down, and what did I say, 1,230 I think? Is that what I said? Yep. Let's check our answer. Happy sounds? Come on, baby, you can do it. Happy sounds we get. That's it for the lesson, guys. Make sure you give me good quality supporting work on your homework, just like I've been showing you in every problem of this lesson, so that you can get good credit. I look forward to hearing your questions tomorrow.